Alright, we're back with part 2 of section 11.1 of our pre-calculus 12 course. And I want to begin today's lesson just by looking at a question we did last day. So last day, remember how I asked you to find the number of different arrangements of, let's say, 4 items? So let's consider the 4 items to be A, B, E, and F. So how many different arrangements were possible? So remember how last day we did the 1, 2, 3, 4 lines, and we said, okay, first one had 4 choices, then one of them's picked, so now we have 3, then 2, then 1. And then by the fundamental counting principle, we multiply them together. That'd be 24 ways, or we introduce this notation called 4 factorial. Good. Now today what I want to do is look at what happens if we were to permutate repeating objects. So instead of having individual objects distinct, now let's say we have some repeating. So here's our first investigation. What happens when 2 letters are the same? Meaning, let me change all the F's to the E's in the list below. Okay, so that becomes an E. E, and you do the same thing, please. Okay. So as you do this, see if you can figure out what's going on. I know there are duplicates. How many duplicates? And ultimately, I guess, how many ways can you see? Got an answer yet while I keep doing this? I guess you should do it in your notes too. These seem to be the same, right? Same. Same. I think you get the idea, eh? So it looks like now I have 2 are always the same, so I cut my list in half. It's 24 divided by 2, or I guess 12. Okay. So, oh yeah, I should write it down here. Seems like half as many. Okay, so that's 12. Now, what about when we've got 3 letters being the same? Okay, so now I want you to change all the F and E's to B's. Okay. Yes, please do it in your notes. Notice anything yet? Notice anything yet? Notice anything yet? It looks like now these are all the same. 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 So now looks like there's only 1/6 as many. And that leads to only 4 different ways. Okay. Now think about what we just did. We started with 24. Right? Or 4 factorial. And notice that when I had 2 letters the same, then I had doubles, or you can think about dividing by 2. Now remember how we use factorials? Well, wasn't 24 the same thing as 4 factorial? And what's 2? Well, that's, 2 factorial. Let's see if that pattern holds for the next one. Okay, we've started with 24 once again, right? Yeah, that's 4 factorial. And then we saw 1/6 as many, so we divided by 6. Once again, 24 is 4 factorial. What is 6? Yeah, if you remember, that's 3 factorial. Seems like what you do is when you have, like, I don't know, 3 letters the same, you divide by 3 factorial. What would you predict for 4 letters that are the same? Yeah, probably 4 factorial. So it seems like when you have repeating objects, treat the question as if they were all different. Right, that's like the n factorial part. But then divide by the factorial of the number of repeating objects. Now, if that is too complicated for you to understand, then that's what this little scroll here says. The number of permutations of n objects, okay, in general, n, the total number. And in this case, which there are a objects of one kind, so there's that repeating part. You could have another b objects of a second kind, and c of a third kind, and so on and so on. Maybe d of a fourth kind, e of a fifth kind, and so on. But the idea is to take n factorial, so treat it like there's no repeating objects, and then divide by the number of repeating objects. So a factorial, b factorial, c factorial, and so on, dot, dot, dot. Okay? That's the formula of how to permutate repeating objects. So let's put that into play. All right, page 2. Determine the number of permutations of all the letters in the following words. Papaya and statistics. Papaya. So notice there's, I guess the formula says treat it like they're all different. So how many letters are there? 1, 2, 3, 4, 5, 6. 6 letters, right? So treat them like they're all different, so that's 6 factorial, but now we have to divide by the number of alike terms. So look, there's 3 p's, right? Oh no, sorry, there's 2 p's. Okay, so I guess I gotta divide that by 2 factorial because they're repeating objects. And then I see 3 a's, so I guess I have to divide this by 3 factorial. I guess there's 1 y, so I guess I could put in 1 factorial here, but 1 factorial is just 1, so most people don't write it in. So I guess this is it by the formula. So 6 factorial, I'm going to have to evaluate 6 times 5 times 4 times 3 times 2 times 1, which is just 3 factorial. So that's nice because it cancels out. 2 factorial is just 2, so how about 6 times 5 times 2? So that's just 60 ways. Okay, statistics, same idea. So let's take a look at statistics. How many? Let's treat them all different. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Treat them all different. Now let's see what's the same. So S, let's see, there's 3 S's. Okay, so 3 S's. T's, 1, 2, 3. Oh, 3 T's as well. Okay. A's, there's only 1 I. There's 2 I's. Okay, so divide that by 2 factorial. T we've done, C is just 1. Okay, so there we go. 10 factorial over 3 factorial, 3 factorial, and 2 factorial. You want to evaluate this? That's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, 2, 1. That's 3 factorial. Got 3 factorial, 3 factorial, 2 factorial, so at least one of the 3 factorials disappears. 3 factorial on the bottom, I guess that's the number 6, remember? 10. So let's just rewrite out 3 factorial as 6, and then write out the 2 factorial as 2. I guess 6 is good, so those just disappear, and that simplifies to 2. So that's 10 times 9 times 8 times 7 times 10. Doing that in your calculator if you wish, but I think the number is 50,400. So lots of different ways. Okay. Let's keep going with a few more examples here. Oh, that true or false test now. Last time it was multiple choice, this time it's true or false. True or false means there's two answers, true or false. How many possible answer keys are there if Mr. Lee decides that 4 answers are to be true and 6 answers to be false? So I guess you're thinking, I've got a group. It's like this. I have T, 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 and then F, 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 F. Now it doesn't have to be in this order. I'm saying what can I have if I were to scramble them up. But if I were to treat them as different objects, there are actually 10 different objects. But we know that there are 4 that are the similar or same, true, and there are 6 that are similar. So we do that. And then you can calculate this. That's 10 times 9 times 8 times 7 times 6 factorial. 4 factorial, 6 factorial. Goodbye, goodbye. What's 4 again? 4 factorial is just 4 times 3 times 2 times 1. And I'm just going to do some simplification. 4 and 2 gives me 8, so those disappear. The 3 and the 9, that's 1 and 3. So I have here 10 times 3 times 7. How about 210 different ways? Okay. Same kind of principle applies when we do these type of questions, the pathway type of questions. Okay, think about this. How many paths can you follow from start to end? As long as it's symmetrical, this works, okay? If it's not symmetrical, then no, but if it's symmetrical, this works. If it's not symmetrical, what you'd have to do, by the way, is do like this. Start here, move there, there's one way, right? Start here, move there, that's one way. How many different ways can you get to this spot? Well, one from the top, one from the bottom, so that's 2 ways. How about down here, that's also 1, that's also 1, that's also 1, that's also 1. And then how do you get to this point here? Well, there's one way there, there's 2 ways there, we add them together, that's 3, and 4, and 5, and 6, and so on. But I don't want to show you that way right now. I want to show it to you using this idea of permutations. If you pick a pathway, okay, you can pick any pathway you want. Doesn't matter. I'll pick one. Okay, so what did I do? I went right 1, down 2, right 2, down 2, right 3, down 1, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. Now, that's one pathway, but if I were to do the other ones, all I'm doing is just rearranging the R's and the D's. Ultimately, I'm still going to have to go down 5 times. And I'm still going to have to go across to the right 7 times. So if you think about it, that's the same thing as 12 factorial divided by 5 factorial, 7 factorial. Okay? And then, of course, we'll calculate that. 12 factorial, that's just 12 times 11 times 10 times 9 times 8 times 7 factorial. Goodbye, goodbye. What's 5 factorial? Excuse me. Five, 4, 3, 2, 1. Lift off. Well, 5 and 2 is just 10, that's gone. 4 and 3 is just 12, that's gone. So 11 times 9 times 8. 99 times 8, how about 792? Okay, you can double check this in the calculator. But I'm pretty sure I'm right. Alright, so turn the page. Got a few more examples. My multiple choice test again. This one has 12 questions on it. 5 of them have A as an answer, 3 of them have B as an answer, 2 of them have C as an answer, 1 of them is D, and yes, the dreaded none of the above, which doesn't really make it multiple choice anymore. But none of the above, one of them. So how many different answer sheets can be created? Well, I think you should be able to try this one. So I'll be quiet and you guys try it, and let's see what you get, okay? Now, once again, if you want to write down 1 factorial, 1 factorial you can, but once again, not really required. You can go and try to calculate this. I'm going to actually do it on the calculator. Yes, you can if you have a graphing calculator. 12, and that factorial key is you press math, go over to PRB, and choose number 4. Yep. Divide by, make sure you put a bracket around here, 5, once again math, PRB 4, times 3, math, PRB 4, times 2, math, PRB 4, and let's see what you get. Wow, 332,640. 332,640 ways. Okay, and I did this one by the calculator. Did by calculator. You can do it by hand too without the calculator, just like I did on the previous ones. It will work as well. Alright, one more example to finish off part 2. Okay. You know what's on my shelf? Yeah, that's right. I've got calculus textbooks at home. I've got math textbooks at home. I got statistics textbooks at home. Okay, now just to let you know, these are 2 identical calculus books. Okay. Yes, I carry identical copies. 3 identical copies. 2 identical copies. Okay, of statistic books. Well, how can you arrange these things now? If I change things up, I said, hey, the 2 calculus textbooks must be together on one end. So I guess the calculus textbooks could be like here on one end, at the front, right? So you have your 2 calc books, and then afterwards, I guess there's 1, 2, 3, 4, 5 more choices. Or I guess I could have had the 5 choices first, and then the 2 calculus books at the end, right? But you see how the 2 calculus books kind of create only one spot. So instead of actually, instead of actually having, how many spots are this? 1, 2, 3, 4, 5, 6, 7. There's only now 6. Okay, but these spots are also fixed, so they must be at one end. Well, what can you do? Well, if you look at this, since it must be there, then I guess there's only one way of that happening. And then now we've got a way of organizing 5 different books, but because they are identical, or at least some of them are, then this part here just becomes 5 factorial divided by 3 factorial, 2 factorial. And then if you were to calculate that, what's 5 times 4? I'm just going to do it in my head. 5 times 4 is 20, number 2 is 10. So I think there's 10 ways over here. Okay. Well, doing the same thing over here, 5 books, 3 factorial, 2 factorial. Let's see, 5 times 4 times 3 times 2 times 1. 3 times 2 times 1 is 5 times 4 is 20. Yep, same idea. Still 10. So 10 in one way, or 10 another way. So how many ways in total? Or means just adding. We're talking about the combination, so 20 different ways. Okay. Now this is because they had to be on one end. Okay. Now in part B, I'm saying, well, the 3 math textbooks must be put together. Okay. Together is better. So what are we going to do with the 3 math textbooks now? Okay, well, they must be put together. So 3 math textbooks now become 1 unit. Okay, and they can move around. So there's still 2 calculus textbooks, right? And there's still 2 statistics textbooks. So now there's 1, 2, 3, 4, 5 different slots. Okay, but this has to be together all the time. Together. But just treat that like one book then, okay? One big book. So once again, it's still going to be 5 factorial, so 5 factorial. And then now we have 2 of the same thing, the 2 calculus textbooks. We have 2 of the same thing, the 2 statistics textbooks, and that one identical, or not one identical, one big group of math textbooks that we treat as one item. So you can say 1 factorial there if you want, but I won't. So let's put an equal sign. 5 times 4 times 3 times 2 times 1. 2 times 1, 2 times 1. That just disappears the 4. 5 times 6, that looks like it's 30 ways. And the last one today, the 2 calculus textbooks cannot be all together. Wow, lagging big time. Too far. Okay, let's hope this works. The 2 calculus textbooks cannot be all together. That means I have to separate them, right? Think about this one. So, the 2 calculus textbooks cannot be together. Well, I think we should split this up into actually 2 different questions. And I think we need to think about, well, let's just treat it where it's a general question, where we just have how many ways can 2 calculus textbooks, 3 math textbooks, and 2 statistics textbooks be arranged on a shelf, okay, in general. So I just say the general way, okay, general way. Like just assuming 2 calc, 3 math, 2 stats, okay? But that, of course, includes all the ways that they are together. So we need to then subtract, right, the ways the 2 calc texts can be together. And if I look at the different ways, the general way and then the way that it can be together, if I subtract them, then I should get the number of ways that the 2 calculus textbooks cannot be all together. So this equals the number of ways the 2 calc texts can't be together. Okay? Alright, so let's do general way. Just general, way back. How many different books are there? Or how many different items? 2 plus 3 is 5 plus 2 is 7. Okay, so 7 items. And then we have 2 that are the same, so divide by 2 factorial. 3 that are the same, divide by 3 factorial, 2 factorial. Okay, to calculate that, let's see, 7 times 6 times 5 times 4 times 3 factorial, 2 factorial, 3 factorial, 2 factorial. 3 factorials disappear. 2 times 2 is just 4, so that disappears. 7 times 6 times 5, what's that? 30, 210. Okay? So that just simplifies to 210. Let's do the other one here. So we have a minus, minus, minus. The number of ways 2 calculus texts can be together. So if the 2 texts are together, let me just quickly draw a drawing. The 2 texts, right? Calc, calc. And then we have the 3 math and the 2 statistics. So treat as one item, right? One item. So we have 1, 2, 3, 4, 5, 6. So that'd be 6 factorial. Divided by, I guess, 3 factorial, the 3 math books that are alike. 2 statistics books that are like that one big book of calculus now that we treat as one object, nothing's alike. So what do we have here? 6 factorial, 6 times 5 times 4 times 3 factorial, 3 factorial, 2 factorial, 3 cancels out, 2, 6 times 5 is 30 times 2 is 60. So 210 minus 60 must be 150 ways. Coolness. We're done.